6 is about some of the different math functions that are built into Java and how to use them. So there's a set of programs that are in a class called math, and in the math class we can use all the different methods or the different programs that were created and read into there. So for example, if you want to take a um, square root, there's no like symbol that you can use from the keyboard, and so we can use SQRT out of the math class in order to figure out what the square root of something is. So the way you use that, you have to say the name of the class that it comes from. In this case, it's the math class, and then a dot, and then the name of the function. And then inside parentheses, you put down the number that you want to do that to. So let's create a new class for this lesson, and I'm going to call it lesson 6. And I forgot this time to create a main, so I'm just going to grab the main, the definition of a main from a previous class that already had it, and make sure that I have the correct number of curly braces so that everything can work. So we're going to take this double P equals math.sqrt17, and the computer is not giving us any error messages, just a caution that P was never used. If we print it out and run the program, sure enough, it prints 4.123105, etc., which is what it would equal if you try something like 16. We know that should come out to be 4. Sure enough, it does 4.0. So this math.sqrt is how you do square roots. One of the other things we want to start looking at is when we look at methods, which are these little mini programs, how does it work? And what information is there, and how do we use the programs correctly? So when you look at it's called the signature of a method. When you look at the signature, it tells you things about that program or about that method that are going to be helpful to us. So for example, the signature of the SQRT function is right here. The first word in the signature says if you run this program, you're going to get a double back, right? The second thing says the name of the function. And then the third thing is what kind of variable is expected when you run the program. So if you noticed, I ran this one, math.sqrt16. SQRT expects a double, so it converted 16 to 16.0, the double, and then it returned 4.0, which is a double. So the first thing is what's going to be returned. The second thing is the name of the program, and the third thing is what it expects when it's going to do this work. Now, sometimes there are programs that will accept more than one input. So if you run abs, which is going to return the absolute value, if you send it an int, you'll get back an int. If you send it a double, you'll get back a double. Other things can only accept one type of a thing, and so it will convert it to a double and then return a double. So if you see here, there's a number of different things that are part of the math class, which will be pretty helpful to us. Absolute value is math.abs. Powers are math.pow. The way those work is you're going to get back a double. The name is pow, and you're going to send it two numbers. You're going to send it a double, that's the base, and a double, that's the power. So the way that works, if we come and we try to do that, if we say double mypow equals math dot, as soon as you put math dot, it's going to give you a list of different options over here, and you can start typing, and you can type When we type P, it's going to show all the things that have a P in it, starting with things that start with P, and then other things that have P's inside them alphabetically. And then we go O, we can see there's only a couple things that have a PO. Math.pow. You can see that it's expecting two numbers, a double that's it's going to just call A, and another double, and you're going to get back a double when it's done. So I can put in parentheses, and it reminds me, hey, I need two numbers. I can do 4, comma 2, and it's going to convert those both into doubles. If I print that one out, I get 4 to the second power, which is 16.0, and math.pow always returns doubles. So what would I do if I actually want it to be an integer? Well, like we were doing in the last class, instead of this way, I could take that same thing, but if I want it to be an int, I can't just say int in front. I have to cast it as an int. So now I'm going to have an integer myPow, which is the integer casting of the math.pow. If I run it, I get 16. So if you really want to have an integer, you can get an integer. You just have to tell Java that that's what you want. Right? Some other important ones that we'll use, ceiling rounds up. So no matter what it is, it's not going to round down from 5 or down if it's below 5 and up if it's 5 or more. It's just going to round up. Floor will always round down. Min and max will get the minimum of two numbers or the maximum of two numbers. And those are functions that are overloaded, which means they have the two different versions. You can do it as a double or an int for min. You can do a double or an int for max. Some other numbers that we'll talk more about later is random. Random will give you a random number that's a double with ints or with decimal places between 0 and up to almost 1. And so that's going to be really helpful when we're trying to do some different things. Rounding rounds to a whole number. Rounding returns a type that we haven't used before, which is a long. And a long is like an int, except that it uses more data because it can get bigger integers. So int goes from a certain number to a certain number. Double uses twice as many digits, so it's a much bigger number. And then another one that's important is pi. So if we do math.pi, math.pi doesn't have parentheses, but if we do math.pi, we get the value for pi and we don't have to remember what it is or type it in. So quite often, to make that even easier to use, we'll do something like final double pi equals math.pi. And then we can just use capital P, capital I. But if we don't want to declare that, we could use double my area equals math.pi times times 3 times 3. So if my radius was 3, math.pi times 3 times 3, this would be pi times r squared. And so we could get the area of a circle using math.pi. Just be careful to put a times here. Java doesn't know that a number next to a parentheses means multiply because that's not how Java works like it does in our algebra classes. Right. The next thing in the lesson, there's going to be a bunch of different examples, and they want you to think about these. So what would math.abs of d equal? Well, math.abs does absolute value, so it comes out to be 379.22. So there's examples of each of these different numbers, these different functions, right? Next, there's some more complicated, more advanced math. So things that you might have learned in Algebra 2. There's logarithms. Notice that logarithms always do base e. So if you want to do base 10, you have to remember how to convert from base e to base 10. There's also sine, cosine, tangent, arc sine, arc cosine, and arc tangent. So we've got all our trig functions. But those are also always in radians. So if you know the number of degrees, you first have to convert from degrees to radians, and then you can do the logarithm of them. Fortunately, there is a 2 radians and a 2 degrees function. So there's a function that will change from degrees to radians. And then if you do arc sine, you can convert from radians back into degrees to make it easier to use. So I'm going to show an example of that because that's something that quite often students miss. So let's suppose that we have a angle that equals 30, and we want that to be 30 degrees, and we want to find out what the sine or the cosine is. Math.sine of my angle. And we'll print out math.cosine of my angle. And if we run those, these are definitely not the numbers that you would expect if you thought that it was going to do degrees. So what we need to do is convert them into radians. So I'm going to say my radian angle equals math dot 2 radians of my angle. And then I'm going to do my trigonometry on my right angle. And if I run that, you can see that there is some rounding going on, but the sine of 30 degrees is 0.5, and the cosine of 30 degrees is 0.866. So those are the numbers that you would expect to get. What if we go the other direction? What if we have a variable, let's see, let's call it my tan, because I'm going to do the arctan of this equals 1. What angle would give me a tangent of 1? So I can do my arctan equals math dot atan. And if I print that out, if I print that out, I get this strange number, 0.78539. What is that? I don't recognize that number at all. So let's convert that number from radians into degrees and see what happens. Math dot 2 degrees of my arctan, and I'll print that one out. And what do you know? It's 45.0, which is actually the correct answer. The arctan, or the inverse tangent of 1, is 45 degrees. So that's how you use 2 degrees and 2 radians to convert into radians or back into degrees, so you can do trigonometry in Java. Right. So after that, you're going to see the list of questions, and then the project for this one is to do this math and have the program do that correctly. You can see what the answers should turn out to be, so make sure that works out. So notice here, you're going to have to do 3 times pi, use math.pi. You're going to have to do the sine of 187 degrees. Make sure you convert that into radians and then do the sine of that number. And then over here, you're going to have to do the absolute value of the cosine of the 2 radians of 122. So you're going to have to combine that all together in a correct order of operations. Remember, you can use parentheses to help you out a little bit. Over here, we've got a power, so you'll have to use math.pow. And ln means log base e, so you'll use log to do that one.